Hello, my amazing students. This is Mrs. A, and I am back with 8.1, 8.2, and 8.3 homework help. With all of chapter 8, we only have 6 problems to do, so I might just throw them all in one video because we had so little homework in this section. So here is 8.1. So number 31 is our only problem in 8.1. The proportion of adults who use the internet is greater than 0.87. And we are told that in exercises 29 through 32 provide statements that identify the type 1 error and the type 2 error that correspond to the given claim. Although conclusions are usually expressed in verbal form, the answers here can be expressed with statements that include symbolic expressions such as p equals 0.1. Okay, well, the big thing is to first start out with your H sub O and H sub A. The claim is that the proportion is greater than 0.87, which means that H sub O is P is less than or equal to 0.87. Remember, our type 1 and type 2 errors have to do with H sub O. And the type 1 error is when H sub O is actually true, but we reject it. So it says type 1 is actually P is equal to 0.87, but we support that P is greater than 0.87. That would be a type 1 error. A type 2 error would be when P is actually greater than 0.87. In other words, the claim is true, but instead we fail to support that claim, and we don't support this one because we fail to reject this one. So that is your type 1 and type 2 errors, and that is all of the homework in 8.1. So that was not much homework I gave you there. So let's move on to 8.2. The first problem in 8.2 is part A of number 1. And we were told to find the proportion that said yes. If you look at the problem, we had 53% that said yes out of 510. So all we're doing on this one is multiplying 0.53 times 510 and getting 270.3. Since we can't have pieces and parts of people, we just say 270. And that is the correct answer for number 1. So all that one was just a very quick multiplication problem. So that's part A of number 1, and that is your first problem on 8.2. So back with the next one. All right, so the next one we're going to do is this number 9, Mickey D's. We're still on 8.2. Mickey D's, in a study of the accuracy of fast food drive-through orders, McDonald's had 33 orders that were not accurate among 362 orders observed based on data from QSR magazine. Use a 0.05 significance level to test the claim that the rate of inaccurate orders is equal to 10%. Does the accuracy rate appear to be acceptable? Okay, so I wrote all of this down on a board. So here is my analysis of the situation. So we started out with 33 out of 362. And I put that into my calculator, which I'll show you shortly. We have a 0.05 alpha. Our H sub O is going to be that P equals 0.10, because remember the H sub O will be the equal situation. Our H sub A is that P does not equal 0.10, and we are told to use the p-value method. So when I come down here, I've got H sub O is 0.10, H sub A is not equal to 0.10, it's two-tailed. My test statistic is going to be a Z because this is a proportion problem. And I got the negative 0.5606 from my prop Z int, which I'm going to show you, our prop Z test, which I'm going to show you in a minute. And the p-value also came from my calculator. The critical value came from my little Z chart, the little one back here in the back that's at the very end. This one right there. Okay, so we're doing 95%, which is going to be 1.96. So I got that from the book, the 1.96. So now I'm going to show you the calculator. So when I go to Stat and I go to Edit, and I drop down here to the 1 prop Z test. Then I hit enter, and I had already put in the 0.1 because 0.10 was what they told us was the value that we were saying it was equal to. The 33 out of the 362 was the proportion they gave us, but they gave us 33 said that there was a inaccurate order, and then 362 trials. We have a not equal to because of the two-tailed, and then we're going to calculate. And so I'm going to move down here and click that button down there, get down here to my calculate, hit enter, and there is all of my cool information. I get my z-score, negative 0.5606, which is my test statistic, which I had on the other board. And then I have my p-value, 0.5750. Now remember, when my p-value is greater than my alpha, I fail to reject. And since I'm supposed to do a p-value test here, my 0.57 is greater than 0.05, so I will fail to reject. Okay, my p-hat was just my 33 over my 362. And so I've gotten back my z, my test statistic, and my p-value, and so I'm able to use those to make my decision. And if I look at my p-value, which is right here, it is greater than 0.05, which is my alpha, so I would fail to reject. Also, if I look at my test score, my test statistic is not in the tails here. My test statistic is just to the left of 0, but plus and minus 1.96 is my critical value. Therefore, I'm definitely not in the tails. I will fail to reject. So since I'm failing to reject my H sub O, I'm failing to reject that P is equal to 0.10, which was the claim. So it looks like there's enough evidence to support the claim. We'll go back here to the answers and we'll look at the wording. Now remember, we only support when we have an H sub A that is the claim. So we will say there is not sufficient evidence to warrant rejection of the claim that the rate of inaccurate orders is equal to 10%. So I'm looking at 9 there. With 10% of the orders being inaccurate, it appears that McDonald's should work to lower that rate. So that is their assessment of that situation, and that is the end of number 9. Okay, so now we're doing 8.3, number 13, and it reads, Data set 17 course evaluations in Appendix B includes data from student evaluations of courses. The summary statistics are N is 93, X bar is 3.91, S is 0.53. Use a 0.05 significance level to test the claim that the population of student course evaluations has a mean equal to 4. So what we do, take all of that data that they just gave us, and we're going to set mu is equal to 4 as our hypothesis, null hypothesis there, which means our alternative hypothesis is mu is not equal to 4. And that also means we have a two-tailed test here. Our test statistic is still going to be a t-score because sigma is unknown. We're going to have negative 1.638 because we got that from our t-test, which I will show you in a moment. Our p-value we also got from our t-test. Our critical value I got from our inverse t, and I'll show you that. And the decision is fail to reject because our p-value is not less than our alpha, which was 0.05. So I'm going to show you the t-test and the inverse t that gives you those values. And there's the screen, and now I will go show you those t-tests. First thing I did was go to my inverse t so I could get my critical value that goes with this. So I'm going to hit enter now. And now I'm going to use the parameters, inverse t with a 0.025 and a 92 because 93 was our n. And so the 0.025 is the area in one tail. When I enter, I get negative 1.986086, and that is correct. And that's where I got my critical value. which is right there. And I went to stat test, and then I went down to t-test, and I will hit enter. And once I hit enter, I'm going to do this with the stats instead of the data. My mean that I'm testing is 4. I put in all of my important data that they had given me. It's a two-tailed test, so I put not equal to, and now I will calculate. And now once I've calculated, I get my t right here. That is my test statistic, negative 1.637, and my p-value 0.1049, which are here in blue. And then I must make my decision. Okay, and since my p-value, which is 0.1049, is larger than my alpha, 0.05, then I fail to reject. And also, if I did it with critical values, my negative 1.638 is not in the tail, because my tails are plus or minus 1.986. So I fail to reject. So when I fail to reject, that means that there's not enough evidence to reject the claim that the mean is equal to 4. And that is the end of number 13. And we have one more in chapter 8. I thought this one was interesting. This is lead in medicine. Listed below are the lead concentrations measured in different Ayurveda medicines, traditional medicine system commonly used in India. So then they're talking about where they got their data. So then we're going to take a 0.05 significance level to test the claim that the mean lead concentration for all such medicines is less than 14. So here we have a list. So we're not going to do this with stats. We're going to do this with data. So we're going to have to put this into our calculator in our L1 position. So you're going to go to Stat, Edit, and under the L1 column, you're going to list all of your items here, just like I did here. And then we're going to do a one variable stats on this L1 column. Remember, this is under Stat, Calc, one variable stats, and we're going to hit enter. Remember, it will go to L1 by default. We get X bar is 11.05, and the standard deviation of the sample is 6.46. Here I got those items right there. So here's my big board, okay, and I have up here, I have my alpha. I've got my H sub A, which was given to me. That is my claim. And my H sub O is mu is greater than or equal to 14. Here's all my data. And then I've got my statistics right there. So I've got what I need. Now I'm supposed to find my test statistic, my critical value, my p-value, and decide on what to do. Now remember, my test statistic is going to come from my t-test, and my critical value is going to come from my inverse t. So when you plug in your inverse t, you use 0.05 because this is a one-tailed test, not a two-tailed test. And then we have 10 as our n, so 9 degrees of freedom. We get the negative 1.833, and now we go to our t-test. T-test, all of my data is already there. I entered it, and I'm using less than instead of not equal to there. And then I go down to calculate. You see that at the top I've got my t, which is my test statistic of my own data, negative 1.444, and my p-value 0.0913. There's my test statistic and my p-value over there. And now I need to make my decision. Since my test statistic is closer to the mean than my critical value, then I will fail to reject. If I look at my p-value is 0.09, and my alpha is 0.05. So my p-value is larger than my alpha. Again, I fail to reject. Since I fail to reject, I am failing to reject that the mean is greater than or equal to 14, which means that I do not have enough evidence to support the claim. And we have finished Chapter 8's homework. And this is Mrs. A, and may God bless your day.